Hi, everyone. Good morning, good afternoon, good evening from wherever you're joining us from. This is the voice of Lekon Akinsande. I work with Data Science Nigeria, and I have my colleagues also on the call. Please, if you are just joining us, currently I know we have 36 people on the call. Let's just spend the next 1 to 2 minutes just to get to meet one another. So you can just drop your name and wherever you're joining us from on the chat room. Alexa will also help to confirm if everybody can hear me. Your name and wherever you're joining us from. Thank you. Okay, great. So I can confirm everyone can hear me. Thank you. Good to have you, Ezekiel from Ibadan. Good to have you, Umar from Kaduna. Good to have you, Adebare from Ijebu. Welcome, Lawrence from Lagos. Good to have you, Otsun from Lagos. Rabi from Kaduna. Good to have you. Thank you very much for joining. Olabode from Ibadan. Good to have you. This session promises to be an exciting one. This is the first of the 5-day workshop. And if there's anything we can assure you is the fact that you will all leave this workshop, this 5-day workshop, um, transformed technically, because this learning content that we're giving out for you is meant to really transform your skills. It's meant to take you to the next level in Python programming and artificial intelligence. And we are very sure and confident that everyone will surely enjoy this learning session. Without much ado, let's get straight into it. I have just about 6 more minutes to go before my colleagues will take over. Okay, so I will quickly start with the introduction so that in case you don't know who we are, Data Science Nigeria, you can get to meet us and know who we are. Right. So we are all here for the Train the Teacher workshop, and Data Science Nigeria, so about us. We are a registered non-profit organization, and we have a vision to build a world-class artificial intelligence knowledge, research, and innovation ecosystem that delivers high impact and transformational research, business use application, AI startup, employability, and social good use cases, such that in 10 years, Nigeria will become one of the top 10 AI destinations with 20% GDP multiplier impact. Essentially, what we are saying here is that we have a vision, and our vision is to raise 1 million artificial intelligence talent in 10 years. And we've been existing for 4 years, so which means that we have, in terms of this achieving this vision, we have 6 more years, right, to achieve this vision, and then we can look up to bigger things. All right. So I want to establish that this that we have on our screen is a quick snapshot of our milestones in the last 4 years. We have, okay, it looks like my screen is just controlling itself. Okay, so these are some of our achievements. We have our 1 million, over 1 million downloads of our AI for Starter ebook. We also have a knowledge book that contains 17,000 video contents, data sets, seminars for people who are interested in learning AI. In addition, we've done a lot of work online. We have currently over 95,000 views online in terms of our learning contents. We also have trainings that we've delivered face-to-face, where we have over 3,000 face-to-face learning content. We are the #1 artificial intelligence learning community and solution delivery network in Africa. In 2019, we won the Matai Impact Award, which is an award of recognition of our outstanding contribution, right, to making the knowledge of artificial intelligence, knowledge of data science available across Africa. Last year, 2020, right, we won an academic poster, which is called EC Conference, right? At EC Conference, that's Economics and Computation. And essentially, this particular award confers on us, right, that indeed Data Science Nigeria, or put it this way, Nigeria is at the center of happenings when it comes to economics and computation. And I have more interesting things for you. Just this year, as a matter of fact, this very year, if you're following us on social media, you should have seen this campaign. Data Science Nigeria, we emerged as the only African finalist in the X Prize $500,000 Pandemic Response Challenge. And what we are doing here is that we are developing an artificial intelligence model that predicts COVID-19 infection rate and prescribes action for safely reopening society and limiting economic impact while minimizing COVID-19 transmission. Essentially, what we are doing here is that we are hands-on building AI models that can help us solve the pandemic that is currently ravaging the whole world. All right. We have different learning platforms. Before time, I wouldn't go through this, but we have learning platform for all cadres, all segments, from beginners to kids to intermediates to experts to university students to experts like yourself, teachers. We have training content and training platforms for every segment. So we have clubs, you know, clubs in different cities across the country. We have clubs on campuses. We also have training programs one of them which we call AI Invasion, where we take knowledge of Python programming to cities, to schools, and even to villages, to villages. So these are some of the um, our communities. Currently, we have 70 universities, communities in 70 universities and 23 cities in the country. So just flipping through for time so that uh, we will be able to keep to time. We also have the AI Bootcamp. AI Bootcamp is a session where we have, knowledge facilitators come together, international experts, local experts come together to train, Nigerians, to train Africans, right, in the use of artificial intelligence, to solve social and business problems. And these are some of the, pictures from some of our past events in terms of our bootcamp. And the good thing is that the bootcamp translates into job opportunities for Africans. For instance, we've had one of our boot camps. This was, I think, in 2019, where we had KPMG hiring some of our students. We had in 2019 Axemans that also hired from the boot camp. So we also do a lot of industry relevant skill, acquisition, programs, such that the students, the people that we train, can have access to industry data and can solve business problems. And as such, we have what we call the data hack. So these are some of the pictures from the data hack that we've partnered with Access Bank, partnered with Max.ng, and some of our alumni, people who have gone through this kind of training program like you are going through right now, have gone forth to to do great things. And this is Zainab Musa, who won 2018 Alt Prize. Fantastic things. Then also some of our participants, win scholarships to pursue advanced degree in courses of interest, right? So we also do a lot of program with scaling up professionals. We've trained quite a number of companies, Shell, FCMB, IHS, TOA, and quite a number of them. We also do a lot of industry partnership with our AI for Executive, where we have sessions to demystify artificial intelligence and data science for executives, right? And we've been having this since 2017, 2017, 2018, 2019. We also have training programs for professionals, training professionals at our training room in AI, at the AI Hub. But of course, because of the pandemic, we've been doing a lot of training virtually, and this is one of them. We also have communities, communities for the kids and teens. This is just in a bid to offer kids and teen access to world-class skill sets. And the pictures you have right on your screen there just shows you an example of some of our training programs for the kids. We teach them robotics, teach them Python programming, data science. And interestingly, also, we have what we call the AI Plus Club for school. And the purpose of this club really is to number one, get these students, right, to have societies within their school, right, and then outside the boundaries of their school. So the students are able to relate with other community members across different schools, and then we also have knowledge facilitators that deliver learning content to these schools. We also have the AI book. I'm sure a couple of us would have seen the AI book, which is also the first of its kind, which tends to demystify artificial intelligence and Python programming. And the good thing is that this book has secured multiple global endorsements. This is what the book looks like. This is just a snapshot from the book. And interestingly, in 2019, when we had our first Train the Teacher, these are some teachers from across the country who are who were in attendance physically. That was before the pandemic, physically, to learn Python programming and AI. And we are excited that we are doing this again, right online, and we believe that it's going to be fantastic. All right. So let's quickly end this introduction with very important things to note. We're going to be giving out certificates of completion, but there's a requirement. And the requirement is that, number one, training sessions must be joined on Zoom using the same email address used in registration. You will observe that before you were able to join this session, you had to register, right? So we'll be able to track your attendance. And that takes us to the second point, which is at least a total of 80% attendance across all training sessions for the period of this training. So it is expected that you have at least 80% attendance, which means that we have 5 days of this training. You are, number one, expected to show up for all the 5 days if you want to get certified. And then within all the days, because this training is meant to just last for about an hour, 30 minutes. So 80% of 1 hour, 30 minutes, you are expected to be on the call. So which means that at the minimum, you should be on the call for about 1 hour, right? 10 minutes, thereabouts, at a minimum. So we have a way of tracking that. So please make sure you do that. Make sure you attend at least 1 hour of this session. Then the last one is that you must complete. So we're going to be giving out daily quiz. So you must complete this quiz session daily. So after this class, for instance, we're going to send you the quiz and you're expected to complete it before noon tomorrow. So you have a lot of time. This class, we understand that most of you are parents, you are busy, some of you are everyone is busy really, but we're giving you till noon tomorrow to complete your daily quiz assessment. After noon tomorrow, you won't be able to complete it, which means that if you miss it, we wouldn't be able to give you a certificate of completion. So please take it serious, and we believe that we'll have a very good time. Finally, you can download our annual reports just to learn more about Data Science Nigeria here. And you can also visit our website, that's datasciencenigeria.ai, to discover more about Data Science Nigeria. Once again, thank you very much for joining this session. We believe it's going to be a fantastic time of learning together. Thank you very much, and I'll turn the table over to my colleagues. Okay, but before then, do we have questions? Please feel free to use the chat room if you have questions. Okay, no questions currently. Okay, so somebody says, please, how can I get the recording? Yes, recordings will be made available. Recordings will be made available, so it will be sent to your email. All right, no problem. We understand that some of, internet might be an issue fluctuating, but recordings will be made available. Thank you very much. Ezekiel, Fumini, over to you, please.
Good afternoon, everyone. Please confirm that you can.
Yeah, your screen is up.
Okay, yes, we can.
Awesome. So good afternoon, everyone, and welcome to this session. As my colleague, as Olalikon has said, we are looking at having an amazing time, wonderful resources and resource people who will take us through end-to-end really in Python programming and artificial intelligence. So I want to welcome us all once again and welcome to this session. I will just be taking us briefly an overview and an introduction into artificial intelligence. We hear a lot about it. We will not assume that everybody on this call is conversant with the concept of artificial intelligence, because the whole idea of learning Python programming, as we'll be teaching, is that you can go ahead and use this to begin to work on artificial intelligence and other like projects. Okay, so let's get into it. There is so much interest in artificial intelligence these days, and this is for good reason. Everywhere we turn, in mainstream media, in movies, in publications, there's a lot of talk and there's so much going on about artificial intelligence. And why is this so? If we were to ask ourselves, just a quick activity right now, you can just use the chat or on WhatsApp. When you hear artificial intelligence, what do you think, right? Many times when many people hear artificial intelligence, we first begin to think about humanoid robots that are coming to take over the world, or we begin to think about, so I want to hear from us just quickly. What do we think? Robots, exactly. Robots, maybe thinking of a voice or a virtual kind of a person, an avatar that can control our machine. Yes, thank you, Uma Ali. Machine. Yes, 20 more seconds. Let's see what. When you hear artificial intelligence, what's the first thing that comes to your mind? Siri, thank you, Siri. I like that. Siri, you know, machine. Yes, thank you, Damilola. Machine driven by data. Thank you, Olayinka. Virtual reality. Thank you very much. So really, there's thank you. Wow, we have a lot of learned people in AI field here. Chatbots, thank you. So there's so much more to AI than what we think, and that's really just what we'll be looking at today in the next few minutes. All right. So when you hear AI really cuts across so many things, from your Google Assistant to Siri to Cortana, to finding your way with Google Maps, to robots, to when you open YouTube and YouTube is recommending a video for you. How does YouTube know that that's the kind of video that you would like to see? To when you are shopping and they tell your customers who bought this item also bought this. When you go to Netflix and you are told that recommended movies to watch, and you are like, these are the kind of movies I would like to watch, or these are the kind of videos. You are looking for educational videos for the next class, and you keep seeing educational content being recommended to you on YouTube. That's because YouTube has observed that whenever you visit their website, you look for educational content, and they begin to recommend more of this content to you. So this really is, all these things are aspects of AI that come together in different applications for this purpose. So what is, let's now try to define each of these concepts. And more than, really, there's so many different definitions, and it really depends on who you ask. Artificial intelligence really is just a technique, like it says, artificial intelligence. It's a technique that enables machines to mimic human behavior. Like when you talk to your phone and you say, hey, Google, hello, Google. Usually anytime I have the chance to teach younger people or educators about artificial intelligence, I always like to use something that's commonplace, like our phones. See that I just said, hey, Google, in this talk, and my phone actually answered. How can I be of assistance? So that is a phone mimicking a human behavior. When talk to it, can talk back. That's just artificial intelligence, a technique that enables machines to mimic human behavior. When we talk about machine learning, you can see that in the picture, there are subsets. So it's as if artificial intelligence, AI, is encapsulating machine learning. Machine learning is encapsulating deep learning. My colleagues are on the chat and they are available. So you can ask your questions and make your comments on the chat and they will respond to you. Okay, machine learning is a subset of AI techniques that uses statistical methods to enable machines to improve with experience. So basically, machine learning is how machines can learn from experience. And how do machines view experience? For a machine, experience is simply data. Past experience for a machine is data. So as much as the data is, that's how much we can say the machine has experience in performing a task. So if we have 10 years worth of data of a machine performing a task, or of an automated system, or of a digital system, or of a record, we can begin to use machine learning to see how we can improve upon such methods using statistical methods. Okay? So machine learning is how we are able to, I would say also, program computers to be able to solve problems without actually telling the computer what to do. As we will see as we go on, we'll be taught that when you type 1 + 1, you tell the computer what to do. But rather, machine learning will allow the computer learn from the patterns in the experience, in the data. It will learn from the patterns in the experience and in the data, and then it can use that to solve new problems. And deep learning, which is our pride and joy today, where everybody's talking about, our Google Assistant is possible because of deep learning. Our facial recognition, every time we unlock our phones, that is AI, that your phone can recognize your face. And funny enough, it was just in the mid-2000s that facial recognition actually made headway in the world. It's quite amazing that these concepts are becoming real every day. They are here and now. It uses the computation with multi-layer neural networks, right? When we talk about deep learning, we often talk about neural networks and perceptrons. And the idea of deep learning is that we are able to feed the data through a network and layers of different functions. And each function is kind of weighted. And as the data moves through this network, the machine is learning the patterns in the data such that as it passes the data through and through the network, forward, backward, in different ways, really, that the machine is able to learn the patterns in data. And this is usually used for more complex things than machine learning is used for. We will see more about this as we go on. So a simpler definition of machine learning, right? Machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically. Imagine that if you just put the data in the machine, it's able to just improve from experience. All the machine needs is data. You don't need to teach the machine how to do it. Once it has the data, it's able to generate its own solutions without being explicitly programmed. So you don't need to tell the machine that when the door is opened, spray this perfume. When this door opens, spray this perfume. Rather, we could have a data set that shows when the times when the door was opened. What were the sounds that were heard in the room when the door was opened? What was the airflow in the room like when the door was opened? If we have this kind of data for a number of days, we can actually use machine learning. And the machine can observe from the patterns that every time this airflow went this way, every time this sound was made, the door was opened and this perfume was sprayed. So I should also spray this perfume every time I hear this sound. That's the kind of simple explanation or example of machine learning at work. So some machine learning terms you will come across are algorithms, model, predictor variable, response variable, training data, testing data. When we talk about algorithms, really algorithms are just a set of rules or a set of statistical techniques really used to learn patterns from data. There are all sorts of algorithms, all sorts, and they are not just limited to machine learning. Really, algorithms are just a set of step-by-step instructions to solving a problem. How do I get to school? How do I solve this problem? That's an algorithm. And what's a model? A model is trained by using a machine learning algorithm. Simple. After your data is fed into a sum of algorithms, the shape, your data will shape that algorithm to a certain form, a certain pattern to conform it to the patterns in your data. And you have a model. That's your model. So if, for example, when you say, what's your model of the world like? Because that person has been shaped by certain experiences, by certain data. It's similar to that. Predictor variable, we talk about features of the data that can be used to predict the output. So there is not all the features that we can use to predict the output. Everything, for example, every time a bird flew over a house, probably power went out. It doesn't mean that it's the bird that's causing it. You can't use the flight of the bird to say that that's when the power goes out, right? So predictor variables are those features in the data that can actually be used to predict the output. For example, when we talk about COVID, we can talk about exposure to someone that has COVID. We can talk about using a face mask or a nose mask. We can talk about all these things. We can talk about if the person has visited a country where COVID is prevalent, right? But we will not talk about something like if the person plays video games, if the person watches a kind of movie. No, those things have you get no direct correlation or impact on the factor or is a risk factor for COVID, right? So response variable is also the feature of the output variable that needs to be predicted using the predictor variable. In our case of the example we just made mention, that would be COVID, and the variables will be other things. So the response variable will be the likelihood of having COVID-19. Okay. Training data. So we talk about training data a lot, and the machine learning is built really using the training data. And then we have a testing data, which is what we use to evaluate our model. Because how do we know that our model makes sense? How do you know that the artificial intelligence system we have built is good enough to go into the real world? We have to test it. Okay, so machine learning workflow really is define your objective, you gather your data, you have to get your data, prepare the data, explore the data, build your model, evaluate your model, and finally, the most beautiful part, make predictions. Okay? All right, so questions that we usually ask are things like, what are we trying to predict? What are the target features? What is the input data? And what type of problem are we facing? We'll see more of this as we go on. Okay, so first off, one needs to define the objective of the problem, to predict the possibility. Let's say we're using the example of rainfall here. So let's say we want to predict the possibility of rain by studying weather conditions. Step two, we gather the data. So we need data such as weather conditions, humidity level, temperature, pressure, etc. This reminds me of a similar project that I ran where we had to use an embedded system to gather and sensors to gather atmospheric data to see how we could predict whether rain will fall or not. Okay, and then preparing the data cleaning involves getting rid of the inconsistencies in the data, such as missing values or redundant variables, just to better serve our purpose. Okay. So please, just a very important announcement. In the next 10 minutes, we're going to take a group picture. So that's in about next 5 minutes, we're going to take a group picture. So just prepare to put a video on for a few minutes so we can take a group photograph. Okay, I think that's fine. Okay, awesome. So, and we talk about EDA, exploratory data analysis, where we would try to understand the patterns and the trends in the data. At this stage, all the useful insights are drawn and correlation between the variables are understood. You see here is where we begin to look at what's our response variable and what's our predictor variable. Here is where we begin to look at the variables that actually make sense in our data and variables that do not. Example, in our rainfall, if we had in our data the kind of cars that were moving on the road, the day rainfall, I mean, that does not have any impact on the actual rainfall. We could get rid of that data as we do our EDA, exploratory data analysis. And then building a model. So machine learning model is built by using the training set. Then we now feed this data into the machine learning and then use machine learning algorithms such as linear regression, decision trees, etc. And actually, to make it very simple, linear regression is one of the simplest machine learning algorithms. So linear regression is one of the most simple machine learning algorithms out there, and it's quite popular because it's one of the most, it's one of the, okay, I'm slowing down, okay? It's one of the most popular mathematical functions out there, that y equals to mx plus c. And as simple as that function is, it can be used to classify so many things. It can be used to classify whether rain will fall today or not. If we run that model, that algorithm on the data set that is a binary classification, we'll be able to come up with that kind of a result from a simple equation like y equals mx plus c. But what machine learning and data algorithms help us to do is to handle a very large set of data, really, and to be able to scale this to different applications and uses. Okay, so model evaluation and optimization. Machine learning model is evaluated by using the testing data set, and the accuracy of the model here is calculated. And then with this, we know how well we have done. Do we need to get more data? Can this work? Is it possible for this model to actually make sense? Can we do what we want to do with this data? This is where model evaluation and optimization come in. And then finally, after we've optimized our data, we've optimized our model, we make predictions. Finally, the final outcome is predicted. And after performing parameter tuning and improving the accuracy of the model. Okay, so let's move on to supervised learning, where we talk about types of machine learning. Supervised machine learning talks about, supervised learning really is a technique where we teach or train the machine using data that is well labeled. And what does that mean? Look at this, looking at the slide, you see a picture, okay? We have labeled data. We have classification of Tom and Jerry. And we want to know, when we show this computer an image, we want to know which is a Tom and which is Jerry. So before we feed the data into the machine or into the computer, we ourselves must find a way to label every instance of the Tom. We label it as Tom, and every instance of Jerry is labeled as Jerry. So by the time we feed this into the machine learns that, okay, this is what Tom looks like, this is what Jerry looks like. And then every time we now feed it a new kind of picture, the machine can look at it and see that, this is Tom. I have learned from the data you have given me. You have told me which of the part of the data is actually Tom. I have learned from the data. You told me which of the part of this data is actually Jerry. And the machine is able to now make predictions upon any new image that it sees, whether it's Tom or Jerry. That's how supervised machine learning works, such that the data that is fed into the machine is labeled. Really, that's what separates supervised machine learning from unsupervised, which we are going to see now. That the data that is fed into the system is labeled. And by labeled, we mean that each instance is the target variable that corresponds to that data point, to that item, is already linked, or it's linked to that data point exactly. Okay, so unsupervised machine learning, on the other hand, you see on the unlabeled data part that there's no Tom, there's no Jerry. We are not telling the computer which is which. And really, the computer doesn't want to know. And what unsupervised learning does is that the information is unlabeled, and the algorithm acts on that information without guidance. and then the algorithm forms clusters of similar data points. So the algorithm by itself will find the similarities and then cluster them based upon the similarities. Okay, it looks like Tom has white. Now, of course, the computer is not going to think like this, but these are just examples. There are ways that it sees these colors and down to the pixels when we begin to look at convolutional neural networks for maybe image processing or something, or image classification. Actually, this is an image classification problem. And clusters are formed based on the feature similarities. So the machine finds the features in each of the unlabeled data points that it sees, and then clusters them based on these features. Very, very useful algorithms, both unsupervised and supervised, are equally useful. Then we also talk about things like reinforcement learning. It sounds just like it sounds, reinforcement learning, that it's an agent is put in an environment and it learns to behave in that environment by performing certain actions and then observing the rewards it gets from those actions. And the idea here is that when a reinforcement learning system is in play, there is an agent, right? So if this agent wants to know which is Tom or which is Jerry, sometimes there are incentives, sometimes there are ways that we advise the model on which way to go. But basically, the model is exploring, or it could be greedy and not explore so much. I want to be careful and just maximize the rewards. But really, there's that trade-off. But the idea is that the model is exploring and trying to just explore, and then he observes, did I get the answer at the end? What was my reward? And the idea is to see how the model can maximize reward. So every time the model gets it right, imagine there is a kind of reward system, right? And then the model is rewarded. And every time it gets it wrong, there's a penalty. The model is penalized and there's some sort of penalty in that regard. So every iteration, every time it makes a prediction, it notes these things. And the idea is it keeps adjusting itself with every action it takes. Every next action in that environment, it adjusts itself to better maximize the reward. And the idea of that is by the time it maximizes the reward, it's getting the correct answer because it only gets the rewards when it gets the correct answer. Very useful as well, especially in places where the data set may be small or the possibilities are very unique. So here is just a table of what it looks like really. You can see the definition of supervised, by unsupervised, and by the reinforcement learning. The kind of problems that they can solve, the kinds of data, the types of data that they can solve, they can be used on, the kind of training it requires, the approach, etc. So these are also some popular algorithms in line with each of these types of machine learning. Okay, so classification of some, classification of machine learning algorithms as well. We can see regressions or types of machine learning problems really. We have what we call regression problems. There are classification problems and there are clustering problems. And what do these mean? For example, regression, when we talk about regression, we are talking about supervised learning. And the idea of a regression is that the output is a continuous quantity. We are predicting maybe a price. And that price could be anything. It could be maybe 10,000, it could be 10,000 naira and 94 kobo. So the idea and the main aim of this forecast is usually to forecast or to predict maybe the stock price, how much Bitcoin will go for in the next few months, something. And the algorithm is usually linear regression, right? Y equals mx plus c, like we said. Then if we talk about classification, classification is as well supervised, and the output is a categorical quantity. It's either a dog or a cat. It belongs to a category, discrete. It's not continuous, it's a discrete quantity. There is a predefined number of range. There's a predefined range that the possible output can be in. So it's either 1 or 0. It's either 1, 0, or 2. It's either a dog or a cat. It's not a dog cat, right? It's either a man or a woman. It's either a house or a car. It's either maybe a Benz or a Porsche. So all these they are categorical quantities, and the main aim is to compute the category of the data. So another very, very popular example is like today, I'm sure a number of people got the links to the Zoom, but it probably ended up in your spam mail, right? How does the machine know that this mail is a spam, this mail is not a spam mail? And it knows that by classifying the mails is a classification problem. How can I find the features that make an email a spam mail, that make an email not a spam mail? That's a simple classification problem that we see in applications every day when we use our emails. Clustering is an unsupervised learning problem, and it assigns data points into clusters because the machine does not previously know what the labels are, what the data really is, but it can find the similarities. And for data points that are similar, for data items, for items in the data set, the items that you have given the computer that they are similar in characteristics, it will group them together. And that's the whole idea of clustering, that, okay, let's find all the transactions in this account that are fraudulent in nature. A good example is when we watch maybe all these movies and we see how somebody comes on and just they're trying to find the links between criminals, and they're able to tie some accounts, like these are fraudulent accounts. How can you just know that? The idea is there is a pattern to fraud, right? So there are these kinds of data points that show that this is likely to be a fraudulent activity. So by the time we find all the accounts that have those similarities in common, we say that we've clustered them into different groups. A popular algorithm is k-means. We have the almighty KNN, the k nearest neighbors as well, and there are quite a number of clustering algorithms also that are out there. Usually, clustering algorithms also help with geospatial data to cluster the people living in Ibadan together, the people living in Lagos, the people living in the south, in the east, in the north. We can cluster them even without telling the computer that these are the northerns, these are the south, and so on. So limitations of machine learning. Now, machine learning is very beautiful and it's very good and it's able to help us solve so many problems. But machine learning requires features. By the time we start talking about high dimensional data, where the features are so much, machine learning starts to break. A good example, you see that we've talked about quite a number of things. And we've talked about, most of the things we talked about are things that are represented as tables, prices, geospatial data. When we start talking about things like images, how many features do you want to give in an image about what an eye looks like? Imagine trying to describe an eye to a computer. There are so many different features of the eye that we can give, almost infinite. Imagine trying to give the features of the human body. They are almost infinite, almost unique to everyone. So it's called the curse of dimensionality. How can we transfer this? And that gives birth to deep learning, right? So if machine learning was going to find out if it was a car or not, using this example, it will go through feature extraction and try to find all the features that make a car a car. Can you imagine trying to find all the features that make a car, from the shape of the tires? And it's a computer, it goes down to the pixel, maybe the radius of the tire, the radius, the color of the pixel of each dot of the tire, to the windows, all these, they are literally almost infinite. And then it begins to classify them. Let's say it's able to extract all those features, it begins to classify them, and then finally it gives an output. The output may not even be so accurate due to the limitations of this process, these procedures. That was why we have deep learning. Deep learning, on the other hand, is capable of focusing on the right features and actually discovering these features itself through different things, because there's a whole network for each of these features where they can fit in. And as the data passes through those networks, every time it passes through, the computer is learning. It's learning and it's adjusting itself right there and then to be able to better identify these features. And at the end, it's able to say, oh, this is a car. And it's more accurate than machine learning techniques, deep learning, for high dimensional data, data like images, videos, audio. For most of this kind of data, deep learning is more accurate in its approach, right? So for complex problems like object recognition, exactly, it's a very, very big problem. So deep learning is a form of machine learning that uses a model of computing that is inspired by the structure of the brain. Yes. So talking about the neurons, that's why we talk about things like neural network. Okay. So I'm going to end today's module here on deep learning and the neuron. So we'll continue from there tomorrow. But I'm just going to end here that the deep learning is very much inspired by the biological neuron, where we have the dendrite that receives signals from other neurons, the cell body that sums all the inputs, and the axon that transmits the signals to other cells. I'm sure that we can begin to see how this can relate to the computer. That there's a part that is receiving input, and there's a part that is computing all the input together, and there's a part that is transmitting the inputs to other signals. So I'm going to stop here and hand over to my colleague who is going to take us hands-on. You might want to start getting out your Jupyter labs and notebooks and collabs, because we are getting hands-on now. So thank you very much for your time, and let's move on to the next session.
Wow, thank you so much, Fumini, for that wonderful presentation. I think before we start the hands-on, it's time for us to take a group picture. Please, if possible, you can on your camera so that we have it done.
Yay, awesome. I think it's been a fantastic time. Thank you so much, everyone. So let's just do a group chess picture. All right. So taking the first picture of the day. Awesome. Got that. Thank you. I think I should just take one more. Okay. All right. Thank you very much, everyone. Let's continue this session. Thank you.
All right. So good afternoon once again. My name is Ezekiel Adebayo. So I'm a data scientist at Data Science Nigeria, and I'm commonly known as GB journalist. So in this section, I want to show you how to use Python programming. Especially our topic for today will be expression, data type, and variable assignment in Python. So this notebook has been prepared for you, and I'll be using it to take you through. Please, if you can see my screen, let me know. Can anyone see my screen, please? All right, thank you so much. You can see it. Okay, so, all right, thank you. So in this section, our learning, all right.
Yeah, so sorry, please. It seems like I took only the first page, forgetting that we actually have 95 people on the call. So I missed the other pages.
Oh.
So if our participant don't mind, if we can just do this again for another 1 minute, if you don't mind, please. Thank you so much.
Right.
Our video's on, and then we just do this again so that I don't miss it. Thank you so much. Awesome. All right, so I got the first one. I got the second one. And then I got the final one. Thank you so much. Yeah.
So to save some data stuff, you can please off your video now. Okay, so now our topic for today will be how to use Python programming. Especially our topic will be expression, data type, and variable assignment in Python. Okay, so after we finish this material, the first thing that you'll be able to know is that you'll be able to describe various computer languages. You'll be able to work with Anaconda distribution, and you'll be able to navigate through it. And also, you'll be able to work with Jupyter Lab or Jupyter Notebook. So you know how you can navigate through Jupyter Lab interface. Then you'll be able to perform some arithmetic operation in Python. You know different data types in Python. You'll be able to assign values to variable, and you also be guided by naming convention. Then you'll be able to have an understanding of comparison and logical operator in Python. So before we do all this kind of stuff, what is Python? What is programming? So programming is a way of instructing the computer to perform some tasks. So this task could be how to add population of one state with another state. Then maybe how to find the square root of a number like 16. We know that the northern people, they can speak Hausa very well, and also the western, in which we have Lagos, Oyo State, Ekiti State, and other states like that. So they can speak Yoruba very well, and also the eastern people, they can speak English. So the same way is computer understand a language. Now, we have different languages such as Java, C programming, R programming, MATLAB, Python. There are quite a lot of them, so especially this one, Visual Basic. I think some of us in school were taught how to use Visual Basic in school. So why should we learn computer programming? Everyone will agree with me that computer programming is fun. You can actually learn it for fun. Then it also increases your critical thinking, the way you think at times. If you are a good programmer, you see, you think differently from others. Then computer programming also helps us to automate some tasks. For example, let's say I want to be adding numbers, from one to another. You can easily automate that with a programming language. And you agree with me that programmers, they earn more money than anybody. In fact, those data scientists now, they earn more money than a medical doctor, if you can agree with me. And also, programming is a backbone of technology companies like Google, Facebook, even Data Science Nigeria. Since we have different languages, some programming language are meant for data science. I mean, they are good for data science. So for example, Python. So majority of people use Python for their daily data science activities, while some use R programming. And also these ones, they just introduced them, Julia and Scala. They are also used for data science. So what is Python programming? So Python programming language is a general purpose programming language. It is an open software, that is, it is free, and people like you and me are the one contributing to it. So this Python programming was created by this man called Gideon Van Rossum in 1991. So Python is used for data science, some use it for web development, and so on. So why do we need to learn Python? I not C programming. I not Fortran that you learned in school. So the first thing is that Python programming is easy to learn, and the code is readable. That is, all the code in Python programming is just basic English. In fact, some of us here in this corner, in this workshop, maybe we have not seen any Python programming before, any Python code before. We can easily understand it and also tell us what it does. So Python is one of the most popular programming languages. So although there's a lot of open source programming languages, but Python is just superb. These are just some syntax of different programming languages to print just hello world. Hello world is the most basic thing that everyone always learn when they are learning a new programming language. So if you want to print this thing, hello world, in C programming, these are the syntax that you must follow. For Java, these are what you are going to declare before you can just print just hello world. Now in Python, as you can see, teacher who is here, Mrs. Gift, I saw you. You see that you can easily understand this thing, even though you have not programmed in Python before. As you can see, you just type print, then a bracket open, you put a quotation there, hello world, and it will print it for you. Okay, so other programming languages can also be used for data science, especially R. So it is not only Python. So it does depend on which one you know first and which one is easier to use for you. So now we go to the Anaconda distribution. So why do we need to install Anaconda distribution? Since the morning, we have been engaging you on WhatsApp saying that lost audio. Can anyone hear me, please?
Yes, we can. Yes.
All right, thank you. So we are going to be programming with this Anaconda distribution, especially with Jupyter Lab or Jupyter Notebook. And I believe that most of us in this workshop have already installed our Anaconda distribution. And if you are here and you have not installed it, just follow the instruction that was sent to you on the WhatsApp group. Now, how do we navigate through Anaconda? So after you have installed Anaconda, you will have a lot of applications on this Anaconda distribution. Some people have already installed PyCharm. The reason why we ask you to install Anaconda is that everything you might ever need has already been installed, pre-installed for you on the Anaconda. So let us see how we can navigate through Anaconda. All right, so on your search bar here, under the taskbar, you just type Anaconda. Anaconda, as you can see, this is Anaconda Navigator. So if I click on it now, a window, sometimes it can take some time, like 1 minute for it to be launched. So you have something like this that I already put or embedded for you on the Jupyter Notebook. So it's still loading, it's still loading. I'm going to wait for it. So I just type Anaconda Navigator on my taskbar and it's still loading. So under this Anaconda Anaconda distributor, we have different applications. So the one that concerns us for today is just Jupyter Lab or Jupyter Notebook. So once this thing is finally launched, you'll be able to launch your you'll be able to launch your Jupyter Lab. So what is a Jupyter Lab or Jupyter Notebook? So Jupyter Lab or Jupyter Notebook is a web application that allows you to create and share documents that contains a code, a text, and maybe a chart or images. So Jupyter Lab allows you to do all these things. So you can easily do your coding here, as I have done it in my own place here. I have my codes under this notebook. I also have some explanatory text such as this that you have seen so far. And also a visualization. You can embed different images from Python, from maybe your picture or any other thing. Like this one now, this is an image and I embedded it. So this is what Jupyter Lab Notebook or Jupyter Notebook allows us to do. But if you are using PyCharm, you may not be able to embed some charts in your script. It will just be a pure Python script. You'll not be able to have some explanatory text, like maybe you want to explain what a code is. So it may be very difficult for you. But with the help of Anaconda distribution, which are different apps like Jupyter Lab, Jupyter Notebook, and others, you'll be able to have everything done. Okay, so this guy is ready, as you can see now. So this is my Anaconda Navigator, and I have different applications, such as the one I know is Jupyter Lab, Jupyter Notebook. You can see Spider. So Spider works like PyCharm. So it's just IDE that allows you to code in Python. So you can use Spider. You can use, this is also PyCharm. PyCharm is also pre-installed here. So if you want to install it, just click install and it will install for you. Okay, so that is it for now. So now I've talked about Jupyter Lab or Jupyter Notebook. So now the next thing now is to okay, some people are lost. Okay. So now the difference between Jupyter Lab and Jupyter Notebook is that Jupyter Lab and Jupyter Notebook are just Python notebooks, and they help us to do our programming. But the reason why we may want to use Jupyter Lab over Jupyter Notebook is that it has a lot of advantages, such that you can have different scripts under a single tab. I will show you on that. So let me just quickly continue because of our time. So this is just the interface of Jupyter Notebook. So now, how do we launch our Jupyter Lab? The thing to do is that you come to your search bar under prompts. So although there are two ways to do that. So the first thing is maybe through terminal, in which I just type here, come to your task bar and type Anaconda prompt. So under the Anaconda prompt, then you just type Jupyter Lab. So if you run Jupyter Lab now, something like this will show up, and then a window will come out from your browser in which you can easily do your coding. So the other way is to come to this Anaconda navigator and then launch it out directly without coming to the terminal. So for example, you can see here, this is Jupyter Lab. So once you launch it, then your browser, maybe Chrome or whatsoever browser you're using, will come out and your notebook will be showing. Okay, so let me open a new Jupyter Lab for us. As you can see, so when you open a Jupyter Notebook for the first time, you have something like this. And now to be able to do your workshop successfully here, you must know how you can navigate through this Jupyter Lab. All right, the first thing in this place is this, and this is called a cell. That is C-E-L-L, a cell. And this is where you would put your Python codes. And now a cell has two ways at which you can use it. So the first way is a pure Python code. Like for example, if I want to add 2 plus 2 together, 2 plus 2, as you can see, to run it, you just press Shift and Enter on your keyboard. So as you can see, 2 plus 2 is sometimes, because it's a Jupyter Lab, so we can have some simple markdown because it allows you to use markdown. What's a markdown? Markdown is like a text, okay, that allows you to do some formatting. For example, you want to bold your text, you want to embed an image, and many more like that. So for example, let me just say, I love a teacher now, and I bold it. So how to do that one is that I will come here, in this place here, then I will change it to markdown, as you can see. So it has three ways. So in this place, the first one is the code, that is the Python code. The second one here is the markdown, that is the plain text. And the third one is raw. Raw means that it will just be as it is. So we'll talk about the code. The markdown here is like this. So to have a bolded face, I just say, I love a teacher, for example. I love a teacher. Now to run it, so I can just come here and say run. As you can see, this is now in bolded face. So for italic, it should just be 1 star. So I love my mathematics teacher. So then I finish it with another star. Then change the text to change it to markdown. Then I run it. As you can see, it's in italic now. And so therefore, there are a lot of markdown syntax that you can use, but our major concern for today is just Python programming. Okay, great. Okay, so I've talked about a cell, how to change it from pure code to markdown. Then, what are those things? As you can see, 1, 2, 3, 4. Now, let me now explain. So this one, to create a new cell, so you just come to the plus here. And as you can see, you can just click it. and a lot of cells will be open for you, and you can put your code here. And to run it, for example, I want to say 4 minus 2. So to run it, it's either you press Shift and Enter button on your keyboard, or you just come here and press Run. As you can see, this is Run. Okay, so it's telling me something is wrong. Okay, I meant to put a plus here. So come here, and then so it will run the cell for you. Okay, so this place here is for you, is for to cut, to delete a cell. So for example, maybe I don't need this cell, I can just come here and click it. As you can see, it has been deleted for you. Even this one, come here, click it. And all this one that I just opened, I can remove all of them. So this scissors button makes you to delete those unwanted cells. The other one here is to copy a cell. For example, I love this teacher, I want to copy it. Okay, so if I come here and click it, so it will be copied for me on my clipboard. And then let's say I want to paste it here. So this button helps you to paste it, just like Control C and Control V. As you can see, it has been pasted for me. Why this one is to run my cell, and this one is to stop my kernel. So here we are using a Python kernel. As you can see, we have a Python kernel here. So the other thing that I want you to know is that when you save your script, okay, for example, as you can see, export notebook as, so you can export your notebook out. So this one, I want to export it to, can be in PDF, can be in HTML, and so on and so forth. And you can also just download it directly. So if you download it, so it will be downloaded for you automatically. And the extension for this Jupyter Lab or Jupyter Notebook is .ipnyb. Please note that because of your quiz. All right. Okay, good. So we've talked about how to use a bold text, how to use simple text. And now to create a list, these are just marked down, okay? You just put this guy here, the dash here, and then run it and change your cell to markdown. And automatically it will be done for you, as you can see now. So it will be, this just like a bullet list. Okay, so we'll talk about how to create a cell and how to delete a cell. So the next thing now is how to use, Python as a calculator. So I want to add something on the chat area that if you are enjoying this workshop, so that I know if I'm too fast, please let. So if you like the space at which I'm going, type yes. If I'm too slow, type no. I'm speeding, okay, yes, yes. Okay, yes, thank you. All right, the extension format is, okay, let's do it again, is i.ipynb. That is the extension format for Jupyter Notebook. Please give room for question. Please, you can ask your question on the chat room. My colleagues are available to answer it via text. All right, now how can we use Python as a calculator? So as we know, Python supports different calculations. So you can do any different arithmetic operations with Python. We all know that we have different arithmetic operations such as addition, subtraction, multiplication, division, modulus, exponentiation, and floor. All right, let's go on. So for addition, it's just our normal addition sign, that is this sign here. Okay, so for Python, if you want to do addition, you use this sign. This is plus operator. Python call it operator, while mathematics call it symbol. So you use plus operator for addition. For subtraction, the same thing. But multiplication is a little bit different with the way at which our programming language sees it. So if you want to do multiplication, you're going to use this sign. So on your keyboard, you will just type Shift and 8 to have this sign on your keyboard. Division, you are no longer using this, but this. Okay, that is backward slash. You use backward slash. And for exponentiation, that is, if you want to raise a number to another number, for example, 2 raised to power 2. So Python takes it as this. So you are using double star for exponentiation, while you will use single star for multiplication. Please take note. So we have like activity very soon. And for parentheses, so Python also supports normal brackets, and so you just do it. But the only problem that you might likely see is that when you want to do operations like this, okay, so, okay, you have a question. Please ask your question, please. Somebody is raising a hand. Chimaga, are you there to assist, please? What is the difference between, okay, forward slash, okay, I'm coming to it, please. I'm coming to it. All right, so now for this parenthesis operator, although we still come to see it, we are going to use an operator to separate it. It depends on how the problem is. Now for modulus, as we know, modulus, okay, we should get there. So this is just the sign for modulus. All right, so let's take it one by one with examples so that we can see it. I'll be running my script here. Okay, for the sake of people that don't have Anaconda installed or PyCharm, so we have an avenue for you, and it is called Google Colab. So to get a Google Colab, so you just come to colab.research.google.com, and what you will do after that is to come to this side here. You come to this side and create a new notebook. So this Google Colab also work like Jupyter Lab. Okay, and let's see. So it has a cell, it has a Markdown, it has Python code, and many more. So now I'm now in a new Google Colab. So first of all, I can edit it. Don't forget the extension is still the same. That is .ipynb. So I can just say day one, for example. Day one, okay. But the difference between Jupyter Lab Notebook and Google Colab is that this one, okay, works online. So you must have an active internet to work with it. While Jupyter Lab, you don't need any internet. Just have it installed and you can just use it. All right, so let's see. So I can just type 2 plus so I'm still running it. It's still running. It's still running. It's still running. Some take time. So it depends on your internet speed. Okay. Okay, as you can see now, so the answer is 7. Okay, the answer is 7. Answer is 7. So if I want to create another cell, I will just come here. As you can see, now this time I want to say what is 9 plus 1. So you just run it. I will press Ctrl Enter to run it. So as you can see, the answer is 10. So if I want to create a text, I just come here, okay, and type it as well. I love my English No. Yeah, I love my computer teacher. Okay, so you just run it. As you can see, as you are typing it, everything will be shown here. What you are typing will be shown here. And if you just, run the cell or maybe press another thing, as you can see, everything is now displayed. And the other good thing about Google Colab is that if you don't know how to use Markdown, so you can easily play with it. For example, if you want to bold it, just highlight it and press this button, bold. So automatically syntax, that is 2 double stars, as you can see. So now you have it being done for you, and you can create a new cell and so on. So that is how to work with Google Colab. The good thing about Google Colab is that you can also share it with your friend. For example, I want to share it with my colleague, Chimauge. So now I will just say, I'm the owner. I will just look for my friend, Chimauge. Just say, okay. I want to send it to my friend, gift. Okay, I just type it. Okay, I just made you a collaborator. And immediately, I've given her the permission to edit it. So immediately when I send it, she will receive a message that some Ezekiel has made her a collaborator on this script, and she can easily work with me. So, but with Jupyter Lab, that cannot be done except I manually send it to her. Is it clear now? That is different between Jupyter Lab Notebook and Google Colab. So, but for this meeting, I will be using Jupyter Lab Notebook. But you, if you don't have Anaconda installed, you can go along by using Google Colab. I hope there is no question on that. Okay, so the double asterisk is for boldface, while single asterisk is to have italic or whatever you call it. Do you get it now? Funny. Yeah, italic. Yeah, exactly. How I change the bullet text? Okay, so for bullet text, let me just go to it here. Or let me just create a new cell here. Let me create a new cell under this addition. Okay. So for bullets, you can just come here and just type the name of your teacher. For example, I have Lekan as my teacher. Okay, then I'll just put either star or either star. It supports these two, either star or dash or hyphen rather. Fuminiyi, these are my teachers. Okay, and then I changed it to Markdown, and then I run it. As you can see, so it has been done for me. All right, please let's continue. So for addition, we are going to use addition sign. Now for subtraction, we use this minus sign. Okay, so let's run it. 20 minus 15, we have 5. Now for multiplication, let's not forget. So it is this star that we are going to use. Okay, that is 2 times 3. You run it by pressing Control Enter. Now this one, minus 2 times 4. Don't forget, times with Python programming is this star. I know this symbol. Okay, so we have a tip for you. Okay, so sometimes you might make a mistake. It's not a problem. So if you make a mistake, you just try to look at the error and then you correct it. For example, now I want to deliberately make this mistake. So by using star instead of star, as you can see, it's telling me invalid syntax. Reason being that I'm supposed to use a star, but I use a multiplication sign for mathematics. So I just change it to the normal operator, which is a star. Okay. So now for division, we don't have any problem. Division is using a backward slash. So that is 10 divided by 5, we have 2.0, and we can go. Now for exponentiation, that is power. So for power, we use 2 stars. Okay, so 4 raised to power 2 is 16. And I can create another one saying what is 3 raised to power 3. And I'm expecting 27, as you can see. So that is it. Now for modulus. So modulus is when you divide a number by another number, what remains after that division is called a modulus. So for example, when you divide 9 by 2, you know 2 times 4 is 8. The remainder is 1. That is why we have 1 here. So the modulus is what remains after you divide a number by another number. So I want to say what is 18, okay, modulus, 18 modulus, sorry, I can't see. 18 modulus 5. 18 modulus 5 is 3 because 3 times 15, 3 times 5 is 15. 18 minus 15, we have what? What is the remainder, please? What is the remainder? Anyone, please? Okay, let me give another example. Right, 3. Thank you, Chimage. Thank you, Richard. Thank you. So let me give us this activity. What is 17 modulus 5? So what is the answer before I run it, please? 17 modulus 5. All right, 2. Thank you. You are all getting it now. Thank you so much. The answer is 2. All right, thank you. Okay, so there's a function in Python called diff mode. Okay, so this function will allow you to get the quotient, that is the number that goes directly and the remainder, 2 together. So for example, when you divide 5 by 2, you know when you divide by 5 by 2 directly is 2, and the remainder when you divide 5 by 2 is 1. So that's why you're having it as 2, 1. I hope you get it. So let me give another example. Let's say I want to divide 20, that is diff mode. It's a function in Python. So you have it to support 2 numbers. So the number that you want to divide with. So for example, I have 20 there. I want to divide by 3. So what I'm expecting is number that goes directly, which we call quotient, and the remainder. I want to get the 2 all together. As you can see, I have this now. So when you divide 20 by 3, okay, you have 6, and the remainder is 2. I hope we all get it, please. Exactly. In fact, people are very intelligent here. Thank you so much. So we have this class activity for you. Already you know it, so I don't need to display the answer for you. Now, floor division, what does it do? So floor division, okay, round your number to an integer. So for example, when you divide 15 by 2, okay, normally in mathematics, it will be 7.5. That is 7.5, yeah. Now, but if you now use this double division, so Python will just take the integer number, that is the whole number, okay, and remove any one that is remaining. So that's why we're having 15 divided by 2, and that is 7. So when you see this sign, it means we are doing integer division. So what it does is that it converts the number to the nearest whole number. So I want to use another example. Floor 2. So now we have what am I expecting, please? Who can tell me? When you divide 5 by 2, the integer part is what? 5. Exactly. Thank you so much. 2. So the answer is 2. So here we have this class activity for us. Okay. And I believe we can all do it to use addition and subtraction together. division together, modulus together, and yeah, modulus, the exponentiation, the diff mode. Yeah, thank you. So another operation now will be how to use parentheses, how to do some advanced mathematics. So, you know, as you taught us in school, you taught us that when we want to have something that is so complex, we should use BOD mass. And BOD mass is multiplication, addition, and subtraction. But in programming, in Python, we are going to use what is called bed mass. It's still like our normal BOD mass, except with this exponentiation. So we are introducing exponentiation to it. All right. So in this case, let's say I have this operation that I want to do. That is 3 times bracket 2 plus 3. So in this case, remember that my multiplication sign will be this star. Okay, I just include my parentheses and I work. So in mathematics, you ask us to do 2 plus 3, that is 5. It now be 3 times 5 and 15. So Python still obeys all the rules that you taught us in school. Is that clear? Are you all happy, our teachers? Please, are you happy seeing? Yes, yes, no, no. Thank you. So we are just privileged to teach you. All right, so now we have this operation, as you can see, it's a little bit complex. That is 2 raised to the power 2 plus 1. So we can just imagine 2 raised to the power 2 is 4. So 4 plus 1 is 5. So in Python, we use this double star as exponentiation, and you add 1 to it. So 2 raised to the power 2, that is 4. 4 plus 1, 5. Now, another one is this guy. That's example 3. We have bracket 3 plus 2, bracket times bracket 6 minus 1. So it still obeys the law of BOD mass. That is bed mass. The bracket, so the bracket here is 3 plus 2, that is 5. Now 6 minus 2, that is 4. So 5 times 2, that is 10. So don't forget to always use bed mass. All right. Now, sometimes we may have this kind of problem because Python syntax, we not see it with the way you taught us in school. All right. Here we have 2 bracket 3 plus 1. But for Python, what we do is that you need to introduce a multiplication operator here so that Python can accept it. Otherwise, you will get an error. So if you do it directly, that I think everything is fine now. In mathematics, yeah, it's fine. But in programming language, it is not fine in this way. And whatever you learn here also goes with other programming languages such as R, C, Java, and so on. So we have to introduce a star operator before the parentheses. So when I run it now, so I have the answer. Please, hope we are getting it. Is there any problem so far from anywhere? I don't like math too much. Okay, thank you. No problem. This is not even mathematics. All right. So now we have another example here. I'll just talk over it. So this mathematics multiplication will be replaced by this star, and we just work it out. The same thing with this one here. So here, we don't need to introduce any operator before. Okay, so we just work it directly, and we have the answer. Okay, Colab takes time to open. Yeah, it is true. Okay, I'm a very good teacher. Thank you so much. All right. So because of our time, I'm rushing. Let me see the time that I have available. Okay. I'm sorry, please. I'm taking my time. Okay, good. Let's go. So now, so here we have an advanced one, and I believe our teachers are intelligent and they can easily solve this one. So to assist you, please. So we just do 3 plus 2. Okay. So this multiple. Don't forget, this is always a trap because you are just learning a programming language for the first time. So don't forget to change it to the normal syntax, and then walk through and we have the answer. All right, so now comment. So when you are doing programming, it is important to comment your code. So what comment will allow you to do is, number one, it will make you to remember the line of code you have written before. There are some things that maybe you can support with a comment. And if you don't put a comment, next year, you will not even remember. Not that you are dull, no, but things happen and you just forget things. Okay, so comments makes another people to work with you and to understand your code line by line. And it's also good for documentation purpose. So now to do a comment or to comment your code in Python, Python uses this hashtag. We all have Twitter, and we have all used Twitter before, and we have all tweeted before. So we will always remember this hashtag sign. All right. So comments are not run in Python code, so they will not influence your result. So Python always ignore anything that starts or ends with this. So here now I have a comment that is, this adds 2 and 8 together and the result will be 10. So now if I run this guy now, okay, without you even knowing any Python programming, you can easily read my comment and immediately you will know what my code does. All right. So another one here, I'm telling you here that I've not taught you how to import packages in Python, and it will be done later. I will teach you later. But now, to get the square root of a number, we will import a NumPy package and then use numpy.sqrt function. So here now, I've not taught you Python, but immediately you see this, you will know that, okay, Fumeniyi, Lekan, Linda, Payemi, or Ezekiel will teach us this one later. So that is what comment allows you to do. So this is 2.0. Don't worry about NumPy SQRT. You will learn it later. All right, now Python also supports some comparison operators. You may want to compare one number with another number. For example, is 17 greater than 19? So your answer may be yes or no, true or false, and so on. So now we have different operators in Python. Okay. How many hours is this lecture? We will soon come to an end. Let me see what my colleagues are saying. So I'm asking them, please, how many minutes do we still have left?
Hi, Ezekiel. Because we started about 5 minutes into the class, at some point we had to wait for people to join. So let's just use the remaining 5 to 10 minutes maximum to round up, please.
All right, thank you so much, Lekan. So now we have different comparison operators in Python. So example, if you want to know whether a number equals another number, so you use this sign, that is double equal to. Don't forget double equal to. So, but if you want to see whether a number is not equal to another number, you use exclamation and equal to. This one means that it is not equal to that. So this one, we know it already, greater than, less than, they are all comparison operator, and we also have greater than and less than or equal to. So don't forget, greater than or equal to has this sign, less than or equal to has this sign. It's not in the way we have it in mathematics, and that is why we call it a programming language. So here we are not doing mathematics, but here we are learning computer programming language in Python. Okay, for example, I have this first example. Is 5 equal 3? The answer may be yes, no, true or false. So as you can see, computer is telling us it is false. And okay, my friend will still teach us this one maybe tomorrow, or I don't know if it is still in this notebook. So let's say is 5 equal to 5? As you can see, computer is telling us true. Yeah, this one is yes. Why this one is no? So let's say write a code to compare 5 and 6. So here I want to compare 5 and 6. Is 5 equal to 6? So please, can I see the answer on the chat room? Is 5 equals 6? Let's not forget the equal sign that we have in this one will be double and not 1. So we know the difference between 1 equal to and double equal to later. So the answer is, what am I saying here? Oh my God. False. Okay, thank you so much. So is 5 equals 6? So the answer is 4. Yeah, it is false. All right. So I will tell you this first later, maybe tomorrow, but not now. I don't want to waste time on that. So is 5 not equal to 10? The answer is true. Is 200 equal to 100? The answer is true. All right. So the same thing also works with greater than operator. So here you can see 100 is far greater than 30. And that is why the answer is true. Minus 60. This one, everybody can make a mistake here because it's very, is minus 60 greater than 50? The answer is false. All right. But this one too, is minus 6 greater than minus 5? The answer is false. Okay, and we can also play with it later. Maybe we have assignment quizzes to remind us on this. So less than, the same thing is also applied. So it can either be true, or anything we are getting from the comparison operator will either result to true or false. So I don't want to waste time on that. Okay, another quick one before we finish here is data type. So we have been saying true or false, and it's different from the way we have it in school. So T, somebody say, why is it capital T and not small t? Why is it capital F and not small f? And this is what we are going to learn in data type. Okay. Okay, so now Python is an object-oriented programming language. So that is, everything in Python is just full of objects. So there are many different data types in Python. For example, if you have words or text in Python, so we call it string. Okay, and the short notation for that is str. And for number, so number can either be a float or an integer. All right, let's continue from here tomorrow. All right. Thank you so much. So tomorrow we'll come to this and explain it clearer so that everybody understands it. Thank you so much. Link over to you, please.
Awesome. Thank you so much, Ezekiel. That was a very, very fantastic pedagogy session. Thank you. All right, then. We believe that it's been a very, very interesting session. A lot of thank you in the chat box, Mr. Ezekiel, our great teacher. Awesome. Okay, so we've come to the end of today's session. As much as possible, please let's all join this session for tomorrow very early. By exactly 5:30, we would start, so that within 1 hour, 30 minutes, we are done, right? So please, it's important to join in very early. We can also assure you that the recording of this session is being recorded. I will work towards releasing this on our YouTube channel, so that before all of that things being recorded, before 2 p.m. tomorrow, we should have it on our YouTube channel, so you'll be able to join. Right. So my colleagues will drop the link to the WhatsApp group on the chat room, so that you can just click and join the WhatsApp group if you're not already there. So Bukumi, Fumini, please drop the WhatsApp group link so that everybody here can easily just join in case they are not there yet. So thank you very much, everyone. Please have a very beautiful evening. Thank you. Bye-bye. Thank you.